Okay, nitric acid synthesis time. Very, very simple setup here. This is just a regular Lieberg condenser. I believe that's what that's called. I have some cold water running from this bucket here with some ice water in it. That has a pond pump pumping out through the bottom here and then exiting out the top, and then it recirculates the water. Here I have a 2-neck round bottom boiling flask. This one is obviously sealed with Teflon tape, stoppered into the distillation head, and that goes over into the condenser. This is a thermometer port. I just had that sealed off with some Teflon tape. I have that wrapped around the threads here, and I have some Teflon tape over the top because we don't really need a thermometer for this reaction. It's pretty foolproof. Not to mention the nitric acid fumes will eat away the silicone gasket that goes into this thermometer adapter, so we don't really want to use that for this reaction. The condenser goes down here, down to this little arm, and into this 500 milliliter round bottom flask. That will be catching our distillate, which hopefully will be reasonably pure and high strength nitric acid. It's a really, really simple procedure. I'm going to be using 200 grams of potassium nitrate that I got at the hardware store. For its intended purpose is to use as stump remover, but I will be using it for this synthesis. And the acid, which is concentrated sulfuric acid, I also got the same exact store as virgin sulfuric acid drain opener, liquid lightning. This is relatively cheap. I think it's like 12 bucks for this. I think it's a liter. Well, it's probably measured in quarts since I'm over here in America, but essentially a liter for like 12 bucks. And as I said in my previous video about purifying potassium nitrate, this is around $6.50 a pound. So it's pretty cheap to do this. It's not going to cost a whole lot. Probably, I think, not including electricity, I think the whole thing will cost me around $5 worth of reactants. And I guess speaking of heat, I should address that issue. I just have this hot plate that I got at Goodwill for $4. I don't really need stirring for this because it's not really too vigorous of a reaction, especially outside. It's about 50 degrees Fahrenheit out today, which in Celsius, I'm not quite sure. I can't do the math in my head right now. Measuring ambient temperature is about the only thing I use Fahrenheit for anymore. I'm so used to that living over here in America. But anyway, once I turn this on, I'm just going to crank it up to almost max, probably about maybe 7/8 of the way all the way up. And then I'm going to wrap this large 2-neck flask in aluminum foil. I'm going to also wrap this in aluminum foil as well. This in aluminum foil as well, all the way over to here. That way any nitric acid vapors can actually make it, since it is kind of chilly out here, they can actually make it over into the condensing column and actually distill out more easily. That way they're not constantly basically be refluxing into this still head back down to the flask, and that would just, take up a lot more time. You don't need a 2-neck flask for this. The only reason I have the 2-neck flask is because this is the only 1-liter flask that I currently own. And actually, I kind of like the 2-neck flask because it just makes, you can set everything up, have it ready, and then you can add all of your chemicals and stuff in and just put a glass stopper wrapped in Teflon tape. Once you're ready to do the reaction, it's actually quite convenient. I'm obviously doing this outside because this produces nitric acid fumes, which are not that great to breathe in. So I do not have a fume hood currently installed in my fake lab. So yeah, I'm doing this outside. It's very, very muddy out here today. Just got some snow recently, so it's kind of crappy out, but it'll be fine. Like I said, I already have the 200 grams of potassium nitrate measured out in that cup right there. I'm going to measure out 175 milliliters of the concentrated sulfuric acid. Mix those together, put them in the flask, wrap everything with foil, turn the heat on, and just let it go until no more distillate comes over into the receiving flask. Real quick, if you're not sure of the purity of your potassium nitrate and the concentration of your sulfuric acid, this is a pretty good guide to go for whenever you're calculating how much of each reactant you need. So 0.81 milliliters of sulfuric acid per 1 gram of potassium nitrate. That's a pretty good starting point if you're unsure of the concentrations, which I'm not sure how pure this is because I haven't refined it, haven't recrystallized it or anything. In drain opener, sulfuric acid is notorious for being around 93 to 96%, so it's not 98%, which is what you would be calculating for like normal stoichiometry whenever you're doing this reaction. And I am going to, you can see my math, we have 162 milliliters required of the sulfuric acid. I'm bumping that up to 175 just because, like I said, I'm not sure exactly what the concentration of this is. And also, like, I do want it to be slightly, the sulfuric acid, I do want it to be in slight excess just so I know all the potassium nitrate's used up. That way we don't, waste anything. As far as the reason why I didn't put a thermometer in here, like I said, the acid would just eat through the little silicone gasket that goes in here. But also, like, you don't really need, like in this method right here, you don't really need to monitor the temperature all that closely. You can just kind of go by visuals. Like if you're getting a lot of brown gas coming through your distillation column here, and especially out this vacuum port, then that means that you're decomposing your nitric acid into nitrogen dioxides and nitrogen oxides and stuff like that, and water. You can crank down the heat, and that's really all you have to go by. You don't really need a whole lot of temperature control with this, because the nitric acid will be the lowest boiling constituent in this reaction here, because we're using sulfuric acid, which has a really high boiling point, potassium nitrate, which again has a really, really high boiling point, and the product that those two make besides nitric acid is potassium hydrogen sulfate, which is also has a pretty high boiling point. So the only thing that's really going to distill over here is nitric acid and water. So you don't really have to worry too much about temperature control. I guess we're all ready to go. I do have this hot plate up on a lab jack, so I can, crank it up and move it to the height I need, drop it down whenever the reaction is done. So yeah, cool. I'm just gonna add the potassium nitrate into here. I'll add the sulfuric acid, stopper this off with a Teflon tape wrapped stopper, wrap it in foil, turn on the heat, and just go for it. I've only had these on the heat for about maybe 10 minutes, and you can see that there's already a brown haze in the receiving flask. So we are getting some nitrogen dioxide forming and kind of spewing across the condenser into the flask. That's a pretty good indication that the heat is a little too high. So now that everything is starting to get up to temperature, like I said, I'll turn it down to about 7/8 of its full capacity. Let's see how this looks in here. Take a little peek. Can you see in there? Yeah, you see how brown that is? Got lots of nitrogen dioxide forming. Things are starting to bubble. So far, so good. I guess all we can do is just hurry up and wait at this point. Quick little note about distilling. Oh my God, it's so windy out here. And there's a fly in my water bath. Oh well. Whenever you're pumping water through, a distillation column like this, you don't really need the pump to be spewing water out the end. This is a perfectly acceptable flow rate, especially for something like this. Nitric acid is a relatively low boiling, distillate, so the temperatures that we're dealing with aren't really all that high. Starting to get some little droplets right here. So that should start distilling over some nitric acid pretty soon. Quick question some of you might have is, why am I doing this in the first place? Nitric acid is just a really useful acid to have on hand if you're doing amateur chemistry, or any kind of chemistry really. It's one of the only acids that it's the only acid by itself that will dissolve copper. It can be used to create aqua regia for dissolving gold, or pretty much any precious metals. And the biggest reason I'm making this is as a learning experience, because I've never really done this before, and I want to do it, just kind of get familiar with the process. I also cannot find nitric acid online for reasonable prices. Like, nitric acid online is ridiculously overpriced right now because of, like hazardous shipping fees and all that stuff. So I think the last time I saw nitric acid online for sale, it was like a liter for like $97 for azeotropic, which is about 67-ish% nitric acid, which is strong. But the nitric acid that we're making here should be, I'm not going to say it's pure, it's not going to be 100%, but it's going to be probably over 90%. It'll be more than likely what's called fuming nitric acid, and that can always be diluted if you don't need that strong of an acid for whatever reaction you're doing. And yeah, this is just kind of chugging along quite nicely. It seems like the key thing to remember when doing this procedure is to have patience, because this will take a little while. So just let it go, let it do its thing, and then reap the rewards after the whole process is completed. Okay, we'll come back with more updates as it progresses. Progress update. It's been about an hour and I think 10 or 15 minutes. Everything's looking real good. Getting a pretty decent amount of distillate over in the receiving flask. Drops are coming over about 1 every 2 or 3 seconds, which is perfectly consistent with what I expected this to produce. One thing that I did forget to record earlier is whenever this first started like really taking off and like producing nitric acid, a lot of brown nitrogen dioxide was starting to spew out of this. And that I turned the heat down. I tried like trying to make sure that the nitric acid didn't decompose too much by controlling the heat. And it got to the point where it wasn't really belching out nitrogen dioxide too much, but then nothing was really coming over. So I guess with this procedure, maybe things would be better if I had like an actual heating mantle specifically for round bottom flasks. I don't know, but I figured, you know what, I'll just sacrifice a little bit of yield for, it's not going to be as efficient just because there is going to be some loss from the nitric acid decomposing and kind of, you know, going off into the atmosphere as nitrogen dioxide vapors. But if I would have tried to do it as slowly as possible to maximize yield, this would take all day. And it's already been, like I said, over an hour. And I mean, that's a 500 milliliter flask. There's probably about, I'd say, 25 milliliters in there maybe. I still think there's a little ways to go because I still have a lot of stuff right up here collecting. So I'm just going to keep going until the drip rate slows down to almost nothing. But for now, it's perfectly viable. So just keep at it, I guess. It seems no matter how well you have things sealed, you're always going to have some nitric acid vapors escaping from this little vacuum port, which is fine if you're doing this outside or in a fume hood or something. But you can still just barely smell the very slight wisps of nitric acid fumes in the air. It smells like a thunderstorm. Nitrogen dioxide is formed whenever lightning, flashes through the air. It breaks the oxygen-nitrogen atoms, the diatomic nitrogen-oxygen atoms, combines them into nitrogen dioxide. The nitrogen dioxide dissolves into water, makes nitric acid. So that's kind of why after a thunderstorm it kind of smells like nitrogen outside, if that makes sense. That's kind of one of those, like, people say that you can smell the ions in the air. Well, it's part of it, at least, is nitric acid that you're smelling. I shouldn't say this, but I like it. Don't sniff that, though. Just in case anyone was wondering about if it's safe to use aluminum foil for a nitric acid distillation like this, the answer is yeah, it's actually quite safe to use this because nitric acid will attack many, many things, but surprisingly enough, it doesn't really attack aluminum. At least it attacks it at first, but then it forms a passive layer of protection, which prevents the acid from further attacking the metal. It's actually pretty safe to wrap this in aluminum foil. You don't have to worry about it like dissolving or anything. Whereas if this was hydrochloric acid, if like hydrochloric acid vapors were to be leaking out, it would slowly start probably dissolving this aluminum foil. But for nitric acid, yeah, I have no problems with it, at least not yet. And one thing that I do want to say real quick, this is a really, really bad gauge to go by, but one way to tell if your joints are leaking is if your keck clamps start dissolving. Since we don't have any keck clamps dissolving, at least not presently, I think it's safe to assume that we have things sealed up pretty well. Okay, still dripping. It's been right about 2.5 hours. Things are still dripping, but it's slowed down pretty significantly. You can see here at the still head, little joint right here, still getting quite a bit of droplets forming and rolling down the condenser. So there is still a little bit of nitric acid left in the reaction flask. Let this go for maybe about 30 more minutes, and I think it's about time to pack up. It looks to be very concentrated nitric acid. That's good. It's a little yellow due to contaminations of, nitrogen dioxides, and I think a lot of the yellow is actually from hydrogen dioxide instead of, the water molecule being 2 hydrogens and 1 oxygen. The hydrogen dioxide is kind of the opposite. It's 1 hydrogen mixed with, attached to 2 oxygens. And it gives it that kind of yellow color. I'll crank it to just maximum. It was almost at maximum there for the past hour or so, but I'm just going to put it on maximum for the last 30 minutes, and then I'm just going to call it and see what we got. I'm not going to determine a yield. I'm not going to titrate this or anything because there's already a lot of good videos on YouTube about that, but I just wanted to show you my failure or success with trying to make nitric acid. So we'll come back whenever this is all done reacting and end the video. Okay, I'm calling it. This receiving flask is only getting like 1 drop every 10 seconds, so that is just about all of the nitric acid that I'm going to get distilled over. So, kill the heat. Like that. Drop this down. Let's take off the aluminum foil now that we're not worried about. Not worried about any of that. Make sure there's no acid on my hand. And there is the naked reaction flask. You can see it's boiling pretty good, but that's just the potassium hydrogen sulfate. I'm sure there's a little bit of water left in there, and there probably is just a tiny bit of acid left too. But like I said, this is dripping so incredibly slowly for the past 10 minutes. I'm just going to call it here. It's not worth running up the electric bill any more than I already did, just to get like maybe like half of a milliliter over the course of another 20 minutes. Clamp casualty right here. Clamp casualty right there. These are my cheap ones though. These ones came with my distillation set, like my first distillation set that I got off of eBay like 5 years ago. I kind of just want to use these all up. This is a newer one that I got off of Amazon a couple weeks ago, and these ones seem to be way better quality, so they're not cracking. I mean, in these ones' defense, it looks like a little bit of acid vapor did leak through, because you can see it is bleached slightly. Like you can see some of the green has been turned from like a dark green to like a lightish green, but it doesn't seem too bad. A lot of people use sulfuric acid to seal these ground glass joints. I didn't want to do that because I didn't want any chance of the sulfuric acid coming, especially from this joint right here. I didn't want it to, or this joint even, I didn't want it to get down to my nitric acid. So I just kind of went with Teflon tape, which seemed to do the job pretty good. You cannot use like vacuum oil for this, or vacuum grease, because it will absolutely destroy it. Holy Buster. Sorry, the neighbor's dog scared me. Alright, we'll let this cool down. We'll take it apart. You can see the reaction flask here has a lot of nitrogen dioxide in it. Doesn't really mean that we're going to have a lot of like left behind nitric acid in here though, because just a little bit of nitrogen dioxide will discolor apparatus very heavily. It looks like a lot, but if we dissolve this in even like 5 milliliters of water, it would probably barely register on a pH scale. So I'm not too concerned about this, and I'm not going to disassemble this yet because it's still pretty warm. I want this, like you can see, this is going to be a solid block of potassium hydrogen sulfate that's going to have to be either dissolved out or chipped out. That's not a big deal. I at least want to take this stopper off and let this kind of vent at atmospheric pressure for a little while before I start taking everything else apart, especially this, because the nitric acid in this flask is going to have a lot of dissolved nitrogen dioxides in it, and I don't want to take this out and stopper it without letting it kind of, like let off some of those fumes, because if you stopper this right away without letting it kind of vent a little bit, there's a good chance that you'll start building up pressure in whatever container you're going to be storing this in, and whenever you go to take it, it'll go boom, and it'll pop off the stopper, and you'll get, you know, fuming nitric acid all over you or all over the place, which is never an ideal situation. And you can also probably notice that I'm wearing vinyl gloves. I actually hate vinyl gloves for chemistry just because they rip so easily, but I can't really use nitrile gloves for handling concentrated nitric acid like this, and I'll show you why here at the end of the video. But yeah, let me go get a bucket with a lot of water, and I'm going to put this stopper in there, and I'll just use that to dilute all this apparatus as I take it apart. That way I'm not dealing with super concentrated acid all the time. I was going to use this to store any of the nitric acid that I made in, you know, today's synthesis. I should have read the Amazon listing a little more carefully. I thought this was a PTFE stopper. It's actually a polypropylene stopper, which for most purposes is perfectly fine. And this would work even for, I think, azeotropic nitric acid, so like 70 or 67% nitric acid, this would be fine. But fuming nitric acid, I looked up a chart on these stoppers. It'll kind of dissolve that, so we're not going to use that. We'll still use the bottle because this is a very standard, what is it, a 1926 stopper. And I have a little teeny tiny flask over here with a 1926 ground glass stopper, which will fit right in here. Put a little Teflon tape around the stopper just to make sure that it's sealed up properly, and 250 milliliter reagent bottle ready to hold some fuming nitric acid. Let's go put it in. And the final weight of the bottle, stopper, and the acid is 241.4 grams. So what's that? About 100, well, 95? About 95 grams, thereabouts. And this right here is why you do not use nitrile gloves when dealing with concentrated nitric acid. Grab a couple drops, put them on this bit of nitrile glove here. See, that would be very bad if that happened while it was on your hand. Okay, well, I hope this was an enjoyable video for you. I'm going to store this in my lab fridge, and now I have a source of at least relatively concentrated nitric acid. So I thank you guys very much for watching. Let me know what you thought in the comments. See you guys. Take care. Bye-bye.